A curved arrow is an arrow that is curved. Hey there, OChemNinjas. In this video, I want to explain what curved arrows are and why they are so important in organic chemistry. At the risk of being perhaps overdramatic, curved arrows are the most important part of organic chemistry. I would say it's impossible to understand organic chemistry without fully grasping curved arrows. The only other option would be to memorize your way through organic chemistry. People have tried to memorize their way through organic chemistry. People have even passed the course by memorizing their way, maybe even with an A, but you cannot fully understand organic chemistry. You cannot really succeed in organic chemistry. You cannot be a true OChemNinja until you really grasp and understand curved arrow mechanisms. All right, with that little rant out of the way, let's get down to business. What is a curved arrow? This is a curved arrow. A curved arrow is an arrow that is curved. It starts somewhere and it points somewhere else. But there is so much packed into this unassuming arrow. Curved arrows are not random. They're not meaningless. We don't randomly draw curved arrows wherever we want on the page. So what are curved arrows and where do we use them? We primarily see curved arrows in an organic chemistry mechanism. A mechanism is a story that tells us how we get from starting materials to products using these reagents. If the reaction scheme is what I have boxed here in blue, the starting material and the reagents necessary to make the products, the mechanism is the story of how we get there, how we go from the starting material to the product. It's the story of how the bonds are broken and formed and how the electrons move around the molecule and the charges change places until we finally get to our final product. The mechanism details each chapter along the way on our journey from the start to the end. And at every position along the way, every chapter along the way, we see our curved arrow notation telling us that story. This brings us to our first important truth when it comes to curved arrow notation. Only electrons move in organic chemistry. This is very important. Only electrons move in organic chemistry. Charges don't move, bonds don't move, atoms don't move in organic chemistry. Only electrons move in organic chemistry. Now, atoms may change places, bonds may change places, charges may change places as a result of electrons moving, but only electrons move in organic chemistry. And the curved arrow tells us how those electrons move. I have another video that I'll link to down below that goes into much more detail on only electrons can move in organic chemistry. If the mechanism tells the story of how the starting material gets turned into products, the curved arrows are the action verbs that tell how that story takes place. Arrows tell the story. This is really important. Arrows tell the story. Arrows tell the story of the movement of electrons. They tell the story of old bonds being broken and new bonds being formed. They tell the story of how the starting material rearranges the electrons to get to the final product. It's able to do that because the curved arrow means something. There's a lot baked into this curved arrow. So let's break down the curved arrow and talk about what each of the pieces mean, what each of the pieces tell you about the story. First thing to say about arrows is they tell the story of the movement of two electrons. Each arrow shows the movement of a pair of electrons. Every traditional arrow with a traditional arrow head shows the movement of two electrons. We do have different arrows in organic chemistry that can show the movement of one electron. I'm not going to talk about those in this video, but I have a different video that I'll link to down below that goes through all the different types of arrows we see in organic chemistry and explains what each type of arrow means. But the traditional arrow with a traditional arrow head shows the movement of two electrons. Where we start and where we point our arrows is not random. They have a purpose and they have a meaning. The arrow always starts at an electron source. It always starts at a pair of electrons. And it always points to an electron sink. It always points to a place where we can put those pair of electrons. The arrow always starts at a place that has excess electron density and always points to a place that lacks electron density. Traditional electron sources include negative charges and lone pairs and pi bonds and occasionally a sigma bond. These are the common places that we will start our arrows. They always start at a pair of electrons, and these are the common places where we see electron sources. Curved arrows always point to electron sinks, some place that somehow lacks electron density that can accommodate that incoming pair of electrons. Traditional places to find electron sinks include atoms with a full positive charge and atoms with a partial positive charge, some atom that lacks electron density for some reason that can accommodate the incoming pair of electrons. One quick warning I'll give you about curved arrows in organic chemistry is that two curved arrows never start at the same place and they never point to the same place. Electrons flow in organic chemistry. Take, for example, this first set of curved arrows. We start at the pi bond and these electrons flow from left to right through the molecule. We wouldn't have this arrow point to this hydrogen and then some other arrow point right back at that hydrogen. We wouldn't have two arrows pointing to the same place. Similarly, because arrows tell the story, they tell the story of the movement of electrons. This arrow is telling the story of the movement of the two electrons in this pi bond. If I'm using these 2 electrons to attach this hydrogen, I can't also use these 2 electrons to do something else on the other side of the molecule. These 2 arrows can't start at the same place and point in different directions. Arrows tell the story. They tell the story of the movement of electrons. They tell the story of old bonds being broken and new bonds being formed. If I were to use these arrows to narrate the story of this mechanism, what I would say is that this first arrow starts at this pi bond. This arrow tells a story of bonds being broken and formed. This arrow says that we're taking the electrons in this pi bond that used to be shared between these 2 carbon atoms, and we're breaking this pi bond. The 2 electrons are no longer shared between these 2 carbon atoms. Instead, I'm going to use the electrons on this carbon on the end, and this carbon on the end is going to get to use those electrons to form a new bond with hydrogen. This arrow tells a story of the pi bond being broken and a new bond being formed between this carbon and hydrogen. Hydrogen only makes one bond, so at the same time that we're forming this bond with hydrogen, we're going to break this hydrogen-bromine bond. This arrow tells a story of a bond being broken. It starts at the bond between hydrogen and bromine. These electrons used to be shared between hydrogen and bromine. This arrow says that we're breaking that bond, taking those electrons that used to be shared between hydrogen and bromine, and localizing them locally onto bromine as a new lone pair of electrons. That is the story of this first step of the mechanism, and that forms this new intermediate. This hydrogen that we added to this carbon is not drawn in. It's part of the implied hydrogens. There were 2 implied hydrogens on this carbon. Now there are 3. And the second arrow formed Br- that we'll use later in the mechanism. In this second step of the mechanism, we have one curved arrow. It starts at the carbon-hydrogen bond. This arrow tells a story of bonds being formed and bonds being broken, tells a story of the movement of electrons. It says that we're taking the electrons that used to be shared between hydrogen and carbon, we're breaking that bond, and those electrons are going to stay with hydrogen, and hydrogen is going to use those electrons to form a new bond with the adjacent carbon. We are shifting this hydrogen over from one carbon to the other. This is going to form a new carbon-hydrogen bond on this carbon. We're not going to draw that in. It's an implied hydrogen. This carbon had 1 implied hydrogen in the beginning, and now it has 2 implied hydrogens in the new molecule. As a result of that, the positive charge ends up shifting over one carbon. Notice I don't have any arrows showing the movement of the positive charge because charges don't move in organic chemistry. Only electrons move in organic chemistry. This story is the story of moving the electrons. We're breaking the carbon-hydrogen bond, taking the electrons away from carbon, using those electrons to form a new hydrogen-carbon bond. This carbon was electron deficient and had a positive charge. Now it will be neutral when it forms a new carbon-hydrogen bond. And we took electron density away from the carbon on the left, and so now the carbon on the left will have the new positive charge. The arrows tell that story. That entire story is baked into this one curved arrow. There's so much going on with curved arrows. The final chapter of the story is told by this last arrow. We're starting the arrow at a lone pair. We're taking this lone pair of electrons that used to be localized on bromine, and now we're sharing them between bromine and carbon to make a new bond. This arrow tells a story. It tells the story of the movement of electrons, tells the story of new bonds being formed. The new bond being formed between bromine and carbon forms the final bromine-carbon bond in our product. The curved arrows tell the story of this reaction taking place. I'm going to end this video on the same soapbox that I started on. Curved arrows are the most important part of organic chemistry. You cannot truly succeed at organic chemistry until you internalize the story of curved arrows and what they mean and what they tell about a mechanism. If you want to be an OChem ninja, understanding curved arrows is a great place to start. Thanks for training with us today, ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.